So we now have our next panel discussion. This is keeping pace with the advancing technology. And herein we are going to be looking into discussing on more the energy storage technologies that can make wind power more dispatchable. Various technologies like gravimetric energy storage, pumped hydro storage systems, green hydrogen. Also discuss on the accelerated science for materials using machine learning techniques for synthesis, characterization, modeling, design of new and existing materials. I invite our moderator of the session, Dr. Chakradhar Byreddy, Director of Renewable Energy, UL Asia Pacific. Our speakers of the session, Ms. Dorte Kamper, Vice President, Sales and Marketing from LM Wind Power. If I can request our speakers to please join. Mr. Pradip Kumar Dubey, the CEO of Aditya Birla Group. Mr. Shashi Barla, Global Head, Wind Supply Chain and Technology, Onshore and Offshore, from Wood Mackenzie, Power and Renewables, joining us virtually. Mr. Servet Sert, CTO of Senvion Wind Technology Private Limited. And Mr. Sreenivas Naidu, General Manager, Research and Development, ZF Wind Power Coimbatore Limited. Okay, we have our speakers joining us now. So Dr. Chakradhar Byreddy, the Director of Renewable Energy, UL Asia Pacific, is going to be moderating the session. We have Ms. Dorte Kamper, Vice President, Sales and Marketing of LM Wind Power. Mr. Pradip Kumar Dubey, the CEO of Aditya Birla Group. Mr. Shashi Barla, the Global Head, Wind Supply Chain and Technology, Onshore and Offshore, Wood Mackenzie, Power and Renewables, joining us virtually. Mr. Servet Sert, the CTO of Senvion Wind Technology Private Limited, and Mr. Sreenivas Naidu, General Manager, R&D, ZF Wind Power Coimbatore Limited. That I request Dr. Byreddy for the further proceedings of the session. Hand over to him.
Thank you so much. Good morning, one and all. It's great to see a lot of good audience over here, and good morning to the fellow panelists as well. I think this is a very pressing topic right now. I think it's important for us to look at why technology will play a very, very crucial role in the future, also at the present time. We are seeing a lot of inflation, a lot of cost and supply chain issues. I think this is where the technology can come and help mitigate those risks. I think it's going to be very, very important for us. At the same time, I think we also need to ensure that we need to invest in the technology, which means that there needs to be some kind of an investment, which means that we have to ensure that there is a certainty in the market dynamics. That's going to be very, very crucial for the industry. I think that's going to be very, very vital as well. It's not only just working on the cost out, it's also making sure that you improve the efficiencies of the technologies that are available out there. And it's vital for us to ensure that we work along with all the stakeholders in the entire value chain of the ecosystem of the industry. So with this, I'll start with few questions to the fellow panelists. I'll start with Servet. Servet, can you deep delve into the new technologies in the onshore and offshore wind, and how do you see India coming up with these technologies? It's on.
Thank you, Chakradhar. So yeah, it's a long topic, so I have a few minutes, right? So as you said before, you know, it's a matter of cost of energy and cost of energy over the lifetime. I mean, we are many companies making wind turbines. So it's a big part we do similar. We have some differentiations. So the cost of the machine itself is important. India has a bit very special profile compared to all markets with wind seasons. So it's very important to have wind turbines that give the most out in high wind, in lower wind as well, at all wind beams. So that's the performance of the machine itself. Now India is going through a fantastic race of, I call it electrification. So with solar, with wind, so we don't consider solar and wind as competition, we consider as complementary. So I believe the country will see a lot of hybrid, much more hybrid project. Storage is one. Large-scale battery storage, it's still probably a big challenge in terms of cost and in terms of capacity. I would personally believe India will become a country which will combine wind, solar, and hydrogen. It's one of, probably best technology in terms of storage, but also directly to as for use, and especially shifting to onshore. The cost of the turbine in the cost of energy is rather limited compared to the cost of foundation and transmission and so on. And I would believe offshore will actually, in India, will fit also very well with hydrogen technologies. So I hope I answered the question.
Sure, no worries. I think that was quite an insight. Pradip, just a quick query. In your organization, how are you using the machine learning for modeling and designing for the new materials?
Machine learning has evolved as a very, very important tool, and it's going to impact all the areas of technological development. Obviously, we have seen more in case of speech recognition or video processing and all that. They are very common. As far as chemical industry is concerned, I think biosynthesis has adopted machine learning very effectively. In case of material science, last few years have seen a lot of experimentation, a lot of adoption. So still it is at very, very early stage. As we all know, machine learning is all about the quality of data and amount of data. And that's where the challenge has been. I think industry realizes challenge. How do we gear up? How do we organize and structure data? How do we put data more in open domain so that we are able to share and leverage? But if I talk about what is the kind of impact machine learning can have in coming years and decades, if we see typically a material development can take anywhere from concept to commercialization somewhere around 10 to 20 years. But with adoption of machine learning, it can be cut down by 1/5 to 1/10. So it can go down somewhere 18 months to 24 months. But still we are at early stage and a lot more needs to be done.
Thank you, Pradip. So I would like to go with Shashi. He's virtually out there. Hey, Shashi, what do you think of the green hydrogen policy, and how would the wind sector play a vital role in India for the green hydrogen? What are your views?
Yeah, thanks, Mr. Chakradhar. I think it's a great initiative by Government of India to include green hydrogen into the renewable portfolio. And government is targeting 5 million tons of annual green hydrogen production by 2030. And it's, if you look at the European Union here, it's about 10 million tons. And in generating green hydrogen, one of the biggest cost elements is the energy consumption. And anecdotal evidence suggests that today, the blue hydrogen or gray hydrogen cost about $5 to $7 per kilogram. Sorry, it's about, for the renewables, the green hydrogen costs about $5 to $7 per kilogram, while that with the conventional power costs about $3 to $4 per kilogram. And government is targeting to bring down the cost to $1 per kilogram. And if you have to lower these costs, one of the best ways to lower it is through generating renewable power. And it will create additional demand than the existing demand. So it's kind of another additional driver. If you try to look at it, if I were to draw an analogy for this, the growth of electric vehicles in general is also triggering the demand for renewables. So when we look at the base case and the bull case, so this the uptick and the penetration of electric vehicles and the surge in demand for green hydrogen by the end of this decade will certainly propel the drive for renewable electricity. And as a consequence, wind is also expected to play a significant role in generating green hydrogen.
Thank you, Shashi. So let me go to Ms. Dorte next. I mean, you've seen the lowest bid in India was 2 rupees 43 paise per kilowatt hour for the one in Gujarat, I guess. How do you see this particular wind sector evolving from these tariffs? What do you see about that? And is it healthy?
No, it's on. Sorry about that. Yeah, the race on cost has been on for many years in the wind industry, right? The levelized cost of energy has been what we've been talking about for many years. We are seeing a shift towards the value of wind, not only the levelized cost of energy, but definitely the cost is an important factor. And what we have seen globally is that we have now reached a point where wind is competitive. Our role as a blade manufacturer in this whole game is, of course, to design and manufacture the longest, the most slender blade. But we also see that this value of wind, we get into a point where we need to discuss sustainability in a different form than what we've done so far. And what we are focusing on in LM is really to close the loop. So we're discussing, and Servet and I was just discussing that a few minutes ago, the waste in the manufacturing is something that we are addressing. In LM, we have launched what we call zero waste blade, because we need to reduce the waste while we produce our blades. When the blades are installed, we need to take responsibility on what happens when we have to decommission the turbines, what happens to the blade. And in that, we also play in with the different material suppliers to get the right material to put in the blades so we can safely handle the blades after the 20, 25, 30 years of lifetime. And that's, of course, another point where we play in the cost is to extend the lifetime of the turbines, extend the lifetime of the blade. And that's sustainability, but it's also a matter of cost to extend the lifetime and reduce the cost of operating a turbine longer term.
Thank you. Let me go to Sreenivas. What do you think are the technological trends that are happening in the gearbox world? What do you see the innovations that are happening out there in ZF?
Yeah. Being at the heart of the conventional gearbox turbines, the gearbox play a very important role there actually. And at ZF we are really working on different platforms to work on making sure that we come up with new technologies where we can actually reduce the weight basically. That is something we term the coin as torque density increase basically. That is where we are working on to try to see that how we can improve the output of the gearbox and at the same time try to reduce the weight of the gearbox to give a good output actually. So I think conventionally when we used to start, I think maybe 10 years back, if you ask what was our torque density number was close to 100 Newton meter per kg. But now what we have done is that over the years we have developed our gearboxes which are closely touching around 170 Newton meter per kg. So that's an advancement which we are doing. And when we say torque density, it is basically all the technologies related to improving the performance of the gears in terms of its manufacturing and the precision which is there, taking the different types of bearings and then also optimizing our castings. So trying to see that we can give an optimum performance with the same reliability what we are trying to do with the conventional gearboxes which we used to do earlier. So I think it's 10 years back we were thinking of a certain number and we have reached it now, and we are also trying to see that if we can bring that consistency in terms of the performance of the gearbox. So that is what we are doing. So you can also say that I think the numbers which I said 100 to 170 is quite a leap in this industry to say that we are going in that direction with different improvements what we are doing actually. So that's how it is.
Yeah, thanks Srinivas. Servet, coming back to you, I think one of the queries that are raised by most people are, oh, wind is intermittent, right? I mean that's pretty much how they will project. But how do you see that with the combination of energy storage and other solutions? What can wind and the energy storage coexist, and what are you seeing the technological advantages and challenges, and also the forecasting? I mean, that's something that lot more people have interesting queries on that. So what do you see from Senvion point of view?
First, I would like to confirm Sreenivas ZF has done a fantastic journey with the modular platform and gear ratios and even beyond 170. So we appreciate actually. And we appreciate Dorte as well in the reduction of materials. This is one of the key areas where actually reducing the process materials and waste is extremely important for the whole wind turbine. So now to come back on your question, high capacity or LPF, I think how we use it sometimes, high capacity factor wind turbines are a must. You know, we cannot afford to be at 25 or 30%. I think everyone is pushing, especially India is driven by capacity factor to a large extent. So that's one we have to deliver as manufacturers. So now, with a combination of solar, I would say you increase further your plant efficiency in delivering more stable energy. Storage, it is a matter of cost. Huh? Ideal world, the storing energy should cost less than producing that energy, and I think this is the biggest challenge with large batteries, because the cost is still in the extremely high. So at the end, it's a matter of energy. If you store it and you deliver it, if it costs 2-3 times more, then the economics are not there. So there is a big way to go with storage. For sure, it's very efficient for stabilizing the grid. So I believe key areas of improvement as well is the infrastructure, the grid, because you want to also consume your energy when you produce it in not adding very high cost of storage. This is why I would think hydrogen and green hydrogen will have a big role in a combined storage as well with wind and solar, because it delivers that function as well. So I would say wind capacity factor. I think with solar it's a bit more difficult to push on a higher capacity factor, but with wind is possible. So we have a big role to play in wind in this area. And it will be intermittent to a certain extent, otherwise we would have to build more, coal plants and so on, which we don't want as well. So we have to be smart as an industry, also how to collaborate across industries, and not to be just wind or to be solar. And we believe we are competitors. We are not. Okay.
Thanks, Servet. Shashi, coming back to you, I think we know the crisis in the supply chain, right? Right now, in the present scenario, the costs have significantly gone up. What is your view on the global supply chain in the wind industry, and specifically for India as well?
Right. Yeah. Thanks. I think today the industry is kind of facing the commodity inflation, and most of this is an adverse consequences of COVID. And we are reeling out of the commodity inflation, and then we are hit again with the Ukraine crisis. So all of this is driving up the cost of the materials and the supply chain cost. So I think one of the best ways for the industry to succeed going forward is that the stakeholders across the value chain have to share this burden. You can't penalize one section of the industry because of this commodity inflation. And I think if you look at, and this is also applicable to the Indian supply chain as well, and we see that the global export to China, the wind turbine prices have risen by 15 to 20% in the last 4 or 5 quarters. And we anticipate that it will continue to rise for the next 4 or 5 quarters by, again, another 10 to 15%, in the subsequent quarters. And looking at the Indian supply chain, I think it's definitely in a great shape compared to the past times. The companies have invested in expanding the supply chain. And if you look at in the past 24 to 36 months, the trade tussle between US and China which are by far the largest economies, and not surprisingly, also the biggest wind markets today. Most of the companies are dependent on these two markets, and any aberration in the demand of these markets is likely to influence the global equation. Because of the trade tussle, and US is imposing a 25% duty on component imports from China. And this has been a positive news for India. And companies are harvesting India as a next global supply chain hub. If we talk about all the leading Western turbine OEMs are now investing in India and making it as the global nacelle production hub. And as a consequence of this, all the component suppliers are following the suit because they want to be closer to their customers' nacelle assembly factories. And India is emerging as a next contender to China, and its ability to fulfill the US demand and also global demand puts India in a great shape. And not to forget that there is central auctions and state auctions, and about 20 gigawatts of capacity is already awarded, and a quarter of it is commissioned, and you still have about three-quarters of the capacity to be commissioned in the next few years. So I would expect that the Indian supply chain is not only addressing the domestic demand, but there is also ample room for exports and position India as a cost-effective alternate supply hubs to mitigate any future supply shocks within the industry.
So Shashi, I mean, to add on to that, what do you see is the biggest challenge in the next 12 to 18 months in the supply chain?
Today, it's certainly the cost is the biggest pain point as we see, as we stand right now, because the component suppliers and the raw material suppliers and the logistics cost. If the oil prices, if you look at it in the last few months because of the Ukraine crisis, the global oil prices almost twice of that of the average of 2021. And as a consequence of this, the logistics cost is going up, material cost is going up. So I would say in the next 12 to 18 months, it's the company's ability to cost out, and they have to, front load the investments in lowering these costs in order to be well positioned for the future growth. Because I've not seen any industry that has a phenomenal growth as renewables. So we know that the long-term fundamentals are intact, but it's the companies that they have to weather the short-term challenges, and who will successfully bail out of these difficult times are the ones that are likely to consolidate the industry going forward.
Thank you, Shashi. Pradip, picking on to the point what Ms. Dorte has said, which is net zero waste, how are you guys looking at using recyclable materials into the wind turbine components, and what is your view on that?
Sure. We always considered ourselves as important stakeholder of this ecosystem because we believed in renewable energy. And at very early stage, we thought that this wind energy had to compete with different forms of energy. And it will be important, given the nature of industry, that we work on productivity and cost. As I've been hearing cost, rightly so. And we had that realization long back. And we have been trying to do, how do we contribute on that front? How do we bring materials which can improve the productivity, which can be more efficient, which can deliver better performance, reduce weight, and even be cheaper. So that was, first phase of the development where we were trying to focus, and we did contribute a lot to this industry. At the same time, we also foresaw the challenges which industry is going to face, if not today, tomorrow, what is going to happen to all these wind blades. And then we started thinking, how do we really make this renewable energy more sustainable? And fortunately, today we have solution that if it is adopted, all the blades worldwide can be made recyclable. We have been working with academia, institutions, industries, to educate them, partner with them, because our objective is that the whole wind energy should adopt, so that we are able to recover and recycle all the material which goes into blades. Otherwise, it has been huge challenge. By doing that, we solve even the cost problem. Sometimes cost, we are obsessed looking at per kilo, but I think if we look at cost in totality or in terms of life cycle, this recyclable material is going to make it more sustainable and more affordable as well.
Thank you, Pradip. Ms. Dorte, what is your view? Because everybody are talking about the cost, and we know that the cost of offshore wind has significantly gone down in Europe. Pretty much they would expect the same in India, but what are the barriers that you see with respect to the cost in offshore wind, specifically for the Indian market?
The overall barrier for wind projects, onshore, offshore, is for us in the supply chain, that's visibility. It's really important for us to understand what's happening in the market and to have a clear visibility to a range of products, which is then drilling backwards in the supply chain and giving us the opportunity to invest. Because us in the supply chain, and that's all of us, regardless if we are an OEM or we are a blade manufacturer or our suppliers back in the supply chain, we need to know that there's viable business going forward. So one of the biggest keys to have I was about to say low cost, but to have a competitive offshore sector is to create that visibility, both politically, but also in terms of the whole infrastructure around the offshore. That's the most important point, is to have that visibility. And once we have this visibility, it's also to secure a smooth process and to secure the infrastructure is in place. We've seen the cost come down a lot in Europe, as you rightly say, over the last couple of years. But imagine it's so many years ago since we started offshore, and India really wants to do a fast track into that. So there has to be a lot of learnings copied to get that infrastructure right from the beginning, because the cost of failing is so much higher when you're out in the sea than when you have an onshore project. And the whole cost of operating, installing, handling an offshore project is so much higher than the onshore project. So we need to have all that infrastructure around it in place. And the blades, unfortunately, that's our business, is a smaller part of the offshore, because there is so much to the offshore project that needs to be in place. And that's all about, the ports, the installation system, the whole measurement, the preparation, all that needs to be in place to have the cost coming down. And we've seen Europe as in the forefront. As you rightly said, we see the US East Coast coming up, but still, even though we have been speaking in the US for very many years about this, we still only have 5 turbines in the waters in the US. It takes time, and the preparation is very well returned. In the investment of that is very well returned over the projects, because that's the key, to get the right preparation, to get the infrastructure and the visibility of the projects.
Thank you, Ms. Dorte. Servet, I'll come back to you on that. I think that's a very valid point, what she said. But the question is, do we have the skill sets available in the market right now, presently in India, to look at these projects from the offshore point of view?
Yeah.
So what do we need to do to get there?
Yeah, I am myself, quite very positive on skills in India, having lived in the country for a few years as well. So maybe I'm over positive. So I would say overall, yes, India has the capability, has the potential, but for sure needs to partner with countries and companies where offshore is there for some decades. So in terms of know-how and experience, as Dorte explained as well. So offshore is definitively very different than onshore, and everything costs 2-3 times more if something wrong happens. So it is the robustness, the reliability of technology is extremely is even more important in offshore. Now, just want maybe to come on the cost. Yeah, we have a panic in the whole industry on increasing cost, on logistic difficulties, and so on. There's still this still highlights, as well as an industry, we are somehow still dependent also on oil, gas, for manufacturing parts. We are still dependent on rare earth material or rare materials. That's a fact as well. And also politics, that's also part. So I believe this is a good lesson as well to also have each time we are developing the technologies that we are reducing dependencies furthermore. A small part of it is also reducing all the waste, all the waste, transportation. So I still believe personally, wind is to be regional. That's how I see wind in terms of either manufacturing footprint, and it is to come more into a regional industry.
Thank you, Servet. I mean, coming back to the same point, Sreenivas, I think what I heard from Ms. Dorte and Servet is the cost of failure in offshore is quite high. From the gearbox world, how are you looking at it from both onshore and offshore? Is it a very modular approach, or is it something a completely different design altogether for the offshore?
Yeah, great question. I would say yes, as Servet has said, that the reliability and robustness definitely has to be on a higher level. But what we are trying to say is that yes, we are trying to bring up this modular concept into the gearboxes. There are advantages there. The advantages is when we have this modular concept, we try to keep the core of the gearbox same and try to adjust it according to the torque level, which is basically the torque range can be much higher for the same gearbox. And we just try to fine tune the components inside the gearbox to meet that requirements. But yes, the robustness levels and the reliability levels will be kept on the highest level possible, because it's the cost which is involved in trying to repair a gearbox if there is an issue there actually. And in terms of modularity, what we are trying to do is that we are trying to see the different types of wind situations at different parts of the world. And for different parts of the world, we are making a range of torques, and with that torques, we are making different platforms. For ZF, we can say that we are making a platform for 2K, then the 3K, then a 4K, which is basically also approximately translates to a torque of say 2000 to 3000 kilonewton meter, 3000 to 4000 kilonewton meters. So you see, this is when we are talking about these platforms, we are talking about a single gearbox which can be used for a range between the range which I was talking about. So what we do is that we try to see that what step-ups we can do for each of these torque levels to make sure that these gearboxes are meeting the requirement. So we always see that as I think the offshore turbines will be at a higher torque level. So in that torque level, we also see that how we can bring in our technologies inside the gearbox to make sure that we make that core stronger. So and that is where we are talking about this modular. Yes, definitely. When we are talking about this modular concept, it's a beautiful concept, because what is happening is that if you want to make a gearbox for any customer who is coming up in that range, the time taken to make that gearbox, develop that gearbox is much faster. But yes, we also have these challenges, like each of the customer has a different interface for different reasons. But I think that is also one situation that when we say that when it is different reasons, the main reasons are when the interfaces changes, the core of the gearbox remains same. That means the stages remain same, the gears remain same, bearings remain same, but the interfaces we have to slightly adjust in terms of the generator which is needed, or where the planet carrier is going to meet, the main shaft is going to connect to the main gear. And what is the bottleneck there is developing those interface castings, which takes a longer time to bring and develop a product which can come into the market. So I would definitely say that if there is a standardization of the interfaces, the time can be faster. And that will also give us the flexibility to have a good, in terms of volume of the planet carriers or the castings which we develop. That will also help us actually. But I think overall, I would say the modular concept which we are having in ZF is basically to address the different torque ranges across the wind industries, what we are seeing it. And that also helps to make sure that we also try to have a good experience, because we also once, for example, when we develop a first product in a platform, in a modular, we develop that, we do an extensive validation, which also goes for a field, and they try to see that how it is operating. And that knowledge we can use on the other gearboxes which are coming in the platform. So that also helps both as a customer and for also us to gain the knowledge which is going in the field, we bring it back and then try to take it again into the market actually. So these are the different areas which we are working on, but definitely I think it's, I would say it's a very positive thing that we have so many challenges around. At the same time, we also have solutions where we can come and move faster.
Thank you, Srini.
Yeah.
Shashi, coming back to you, what are the kind of improvements that you're seeing technologically, especially on the forecasting, scheduling, and controlling for the advanced electricity markets? Because there is supply and demand, side. So, what are you seeing in the markets, and what are those technological advancements? How can it be implemented in the Indian market? Because the forecasting and scheduling has been one of the Achilles point in the industry. So, what is your view on that?
Well, I think if we take a step back and try to look at renewables, one of the biggest area of improvements for renewables is the intermittency nature of renewables, because they are not synchronized with the demand. So I think that is by far one of the biggest elements that the renewable sector has to collectively address. I mean, wind today on a standalone basis is already at grid parity in most of the markets globally. And if you look at, we have been historically talking about cost, and it is still by far the biggest element in terms of investment decision making. But I think going forward, the fellow panelist Dorte was also mentioning, I completely concur with the point that we should be shifting the mindset from a cost-driven approach to a value-driven approach. I think that's where these kind of technological innovations will play a pivotal role in helping us get there. Because if you look at the operators, the grid operators, all they would want is the standard base load, and they do not care about if it is XYZ of the renewable technologies. So the technological innovation, I would see a great future in the amalgamation of different technologies. And some of the fellow panelists have also cited this, wind plus battery storage, or wind, solar, and battery storage. These will be the lethal combination to provide the base load to the grid for the future. And we will be focusing on a value-driven approach rather than cost-driven approach, because industry has largely won the game of cost already, and it is the time for us to step up and try to look at the societal value that the renewables can generate. And all this, there is a lot of innovations happening. We see hybrid projects becoming very prominent in markets like Australia, in Europe, in the US. So I think and even in India, we've seen quite a few hybrid projects coming up. So I think these kind of new innovations will certainly propel the industry into a different tangent altogether.
Yeah, thanks, Shashi. I think we have talked a lot about the capex side of the business. I think I would like to move a little bit on the opex side, where a lot of technological improvements are happening. So Pradip, what is your best solution to recycle the old turbines? I mean, what are you guys looking at it, and does it mean that we are going to look at net zero for the future turbines that are coming out there?
I think I highlighted earlier that we already have a solution to make blades recyclable. So that's something we need to think through. How do we adapt? How do we create that ecosystem? It has capability not only to recycle at the end of life cycle, but a lot of wastage, at least 5 to 10% waste we generate while making those blades. Even those materials can be recovered and recycled. So that's direct saving of the cost immediate. Probably industry is also facing a challenge. What do we do with the current wind blades? And there are lots of them all over the world. Obviously, the very established or known, whether landfill or incineration, they are not the right solutions. These are the materials which are known for lightweight, high strength and all that. There has been effort to repurpose them, but I'm not sure if it has been looked at very systematically, that how do we really repurpose in smaller components, make it more modular, so that it can be utilized. When I say, make it smaller, the whole blade, you can get a lot of profiles. And if those profiles in smaller modules, it gives a lot of flexibility to assemble in different shape sizes. It could be, I do not know, mobile home, mobile shop, mobile office, or even houses at high altitudes. So it can be repurposed, and I see that industry can benefit a lot by doing that, because there is a need. And here we have a material which has high strength, lightweight, thermally insulating. So even at high altitude, where you want to make it warm, you don't need a lot of energy actually, because by nature of the material, it will keep it warm. So I think in that area, there is a lot of opportunity, but industry need to create some sort of collaboration and see how do we make that happen systematically.
Thank you, Pradip. Ms. Dorte, any comments on that from what LM is looking at it for these old blades?
I think actually the last comment is what I wanted to pick up on, actually, about collaboration, because we think that's the key to these points. It's not what can you say, a problem for one OEM or one developer or one sub-supplier as LM. It's an industry challenge. And it's also an industry opportunity, because as you are saying, it's very good product, and we have, you can say we have an incentive in it, because landfill is banned in many countries. In EU it's banned, so we need to find different solutions as an industry. In LM we are a very strong believer in collaboration on this. We need to collaborate to find a solution for all of us. In Europe there's a consortium we call Decombates, where we are part of it together with the major suppliers like Vestas, Siemens Gamesa, etc., to find solutions that are viable in Europe and elsewhere. We just have to start a place, and collaboration is the key word for it. So the challenge is both on the new production, but also on all the blades that we have out there. And that opens up a completely different avenue that we probably don't have time to discuss here, but about repowering, because we have a lot of small turbines, especially here in India, and it would be great to see them being replaced by bigger turbines producing more energy.
Sure, thank you. One last question to you, Servet. She talked about repowering, right, from the technology point of view. So from the OEM point of view, do you still believe that you could get a class 1 machine into the market if the market exists for you, and then we can have a lot of technological improvements if the repowering market exists?
Yeah. Can I add just one more on the recyclability? I like this topic as well. Yeah, I mean, wind turbines as of today, if we install a wind turbine today, whatever it is, it can be recycled with the right, with the right technologies. We have years, we have decades in front of us. Huh? So it's a matter of investment, and also what you recycle on a cost competitiveness as well. So today it's not competitive to recycle wind turbines with the existing plants. So this can be two ways in designing turbine, because it's true that last decades, OEMs, we have not probably designed with a key focus on recyclability, which is changing, which is good. But we can also develop technologies to recycle the existing turbine, because we will have to do it anyway. Huh? We cannot have all these hundreds of gigawatts and then we have no solution on them. So we will have to develop solution to recycle also the existing turbine, which is different than nuclear, for example. It's hard to recycle nuclear from a technology. So we have this advantage. And now I come back to your question. I just need you to repeat it a bit.
Yeah, so since she raised the point of repowering, is there a market that you believe that you could bring a class 1 machine into the market?
Yeah. So there is two things which also contribute to cost of energy. I believe there is many technologies that have been installed in India in the last decades that is worth to do lifetime extensions. So lifetime extension is also always to consider. So now on repowering, it depends on the different, regulation in countries. Sometimes you cannot just take out 2 times 1 megawatt turbine and put a 3 megawatt on that side, from a grid perspective. But yes, I mean, I don't think in India I have seen many high wind turbine installed in low wind, so I believe you will have, if you repower, it will be the latest turbine technologies, which in the same wind class. That's how I would see it. But always with the economics of, is it better to do a lifetime extension or to repower? Because at the end is a cost. If we throw away wind turbines that life can be extended, is it actually beneficial for the country or the economy? And then India has some good high wind spot as well. So I hope we see some, class 2 or 1 machines in these areas. Yeah.
Thank you, Servet. I will now open the floor for any questions to the fellow panelists, if there are any.
Hello. So maybe a common question to all of the panelists. Do you see anything radical, like next generation after the horizontal axis wind turbine, that could really transform the landscape?
I start first, actually.
Go ahead, Servet. Go ahead.
Yeah, I mean, we have this different type of technologies and innovations and startups, and I still believe the wind turbine with 3 blades, and I hope, Bernard, you would agree, will have still a long life in front of us. But it's always good to see innovation. We always learn from innovation, but I think the industry has proven the current topology architecture is still one of the most efficient from energy production, also lifetime perspective, your business case certainty as well.
If I may add to that, I think the innovation is going to come in a different form than some of the examples you mentioned. I think the innovation we need to do as an industry is in materials, it's in processes, in this continuous industrialization of what we are doing to keep on reducing the cost and increasing reliability. There's a lot of, you can say, hidden innovation in enabling turbines to run longer time. So extending lifetime of a product is a very valuable innovation that we can all do through material innovation, process innovation, etc., and industrialization, what we are already doing today.
Thank you very much. I think we are running out of time, but I will conclude the session by saying that technology is going to play a very vital role in the next coming years. And it is also very important based upon what we have heard from the fellow panelists, that consistency and certainty in the market is what the customers are requiring, which means that can help advance the technologies. So with that, saying that, it's also important that we don't look at competition from a solar point of view. We have to coexist together. I think wind and solar can coexist, and we can solve the net zero problem that is out there. Thank you very much, and we really appreciate for listening to us very patiently. Thank you.
Yeah, thank you to our panelists for the insights. And may I request our moderator to kindly present the mementos to our speakers. And now inviting Mr. Lamai to kindly present the memento, thanking Dr. Byreddy, our moderator. We'll have a group photograph of all of you. Mr. Limai, if I can request you also to please join us for the group photograph. Thank you. And now we